welcome to Cambridge Chemistry channel with Sarwatahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. Today we will explain ionic equilibrium of weak acid. First of all, we should know that what is Bronsted-Lowry theory of acid and base. According to this theory, acid is a proton donor and base is proton acceptor. Consider this example: hydrochloric acid when dissolved in water to form hydronium ion and chloride ion. Hydrogen chloride act as an acid because it tend to donate a proton to the water, while water act as a base because it accepts a proton from the hydrogen chloride. Three important features of the Lowry-Bronsted theory are given. We will discuss. When an acid molecules or ions tend to donate a proton, the remainder of the molecule or ion now capable of accepting a proton, which is a base. For example, in this example, water act as a base. For example, chloride ion is left after HCl has donated a proton itself capable of accepting a proton. Chloride ion is called the conjugate base of HCl. So we can say that hydronium ion is conjugate acid of water, while chloride ion is conjugate base of HCl. HCl gives chloride ion, which is a conjugate base, while water act as a base and gives hydronium ion, which is a conjugate acid. So in each conjugate pair, the acid and base differ from one another by a proton. A strong acid has a weak conjugate base. A weak acid has a strong conjugate base. Similarly, a strong base has a weak conjugate acid and a weak base has a strong conjugate acid. A complete acid-base reaction is merely the exchange of protons between the two sets of conjugates. So, we should know here about the strong acid. What is strong acid? Strong acid is a chemical species which is completely ionized in aqueous solution. For example, HCl dissociate into hydrogen ion and chloride ions. It is completely ionized in aqueous solution to form hydrogen ion and chloride ion. There are other examples like of strong acid like H2SO4, which dissociate into two hydrogen ion and sulfate ion. So there are many strong acids which are completely ionized in aqueous solution. So come to the weak acid. So weak acid is a chemical species which is hardly ionized in aqueous solution. For example, ethanoic is a weak acid which is hardly ionized in aqueous solution, gives ethanoate ion and hydrogen ion. For example, if the degree of dissociation of ethanoic acid in a given aqueous solution is 0.005, then only 5 in every 1000 ethanoic acid molecules are dissociated into ethanoate ions and hydrogen ions. So hence an equilibrium is set up. Hence equilibrium is set up between the undissociated ethanoic acid molecules and the ions ethanoate and hydrogen ion. So for example, CH3 ethanoic acid for example, there are 1000 particles of ethanoic acid before dissociation. This is 0, this is 0, and after at equilibrium we know that out of 1000 particles only 5 particles are dissociated. 5 particles of ethanoate and 5 are and left change the equilibrium will be 995. So at equilibrium the 995 particles are of ethanoic acid and 5 particles of ethanoate and 5 particles of hydrogen ion which are dissociate. Similarly, strong bases are completely dissociated into ions in aqueous solution, while weak bases are only partially ionized. For example, sodium hydroxide completely dissociate into sodium ion and OH ion, while weak base when dissolved in water partially ionized to form NH4 positive and OH ion. This is aqueous and aqueous. This is strong base and this is weak base. It is important to realize that the word strong refers only to the degree of dissociation. Strong word means degree of dissociation of H positive ion and OH negative ions in aqueous solution of acid and base respectively. So strength and concentration of the acids cannot be confused. So careful use of the two words strong and concentrated is very important. Concentrated solution of a weak acid might contain more hydrogen ion. Concentrated concentrated solution of weak acid contains more H positive ions, while dilute solution of concentrated solution of weak acid contain more H positive ion, while ion then a dilute solution. Solution of weak acid. while strong acid has more hydrogen ion dissociation than weak acid.